Okay, in this video we are going to be doing Calc AB Problem Set 26 problems and playlist in the description below. And let's try to do the problems. Find the first derivative of each of the following. So we've got arcsine of 3x, arctan of x cubed, 3 to the x squared, 5 to the inverse tan of x, or the arctan of x. So I need to remember the derivative of arcsine. The derivative of arcsine is 1 over the square root of 1 minus x squared. Definitely worth memorizing, especially for when you have to go backwards, but I mean in this case probably when you go in either direction. So derivative of arcsine, gotta know it. We're gonna need the derivative of arctan as well. So the derivative of arctan is going to be 1 over 1 plus x squared, and now I'm gonna dive in and do parts A and B, and then refresh on the derivative of a to the x in a second. So for part A, we wanna find f prime for arcsine of 3x. So the derivative of arcsine of u is 1 over the square root of 1 minus u squared times the derivative of u. So far I've done blank over square root of 1 minus u squared, so 1 minus quantity 3x squared, and then multiply by the derivative of 3x, which is 3, and then you'd want to rewrite that probably. All right, so next up we have the derivative of, I should have written dy dx. It's like you just get stuck using a notation sometimes. Arctan, so it's going to be 1 over 1 plus the quantity x cubed squared, and then times the derivative of x cubed. The way I usually write it is denominator first, so I'll do 1 plus u squared times the derivative of u is x cubed, so 3x squared. And then again, you would want to rewrite this as just 3x squared over 1 plus x to the 6th. All right, now the derivative of a to the u, or a to the x. This one's really important, not enough people remember it. The derivative of a to the x is a to the x times the natural log of a. So you're just going to multiply by the natural log of a. Now, we also are going to have to think about the chain rule as we do this. So we're finding the derivative of 3 to the something. So that's going to be 3 to that thing times the natural log of 3 times the derivative of that thing, so times 2x. All right, and then I guess you would rearrange it. I don't know. That one, it's messy no matter how you write it. For part D, we're doing 5 to the something, the derivative of 5 to the something. So the derivative of 5 to the something is going to be 5 to that thing times the derivative of that thing's arctan. I forgot the natural log of 5. 5 to the thing times the natural log of 5 times the derivative of the thing. So don't forget the natural log part. As you can see, I just forgot to say it there. It happens. And that's that. Let's take a look at another problem. Okay. A ladder 17 feet long, you can see I had a typo there that I had to fix, is leaning against a wall, and the foot of the ladder is sliding away from the wall, the base of the wall, at 2 feet per second. How fast is the top approaching the ground when the foot of the ladder is 8 feet from the wall? All right, so I'm first going to draw a right triangle. This is basically just a right triangle problem. I'm going to fill in what I know, which is definitely that the ladder is 17 feet long. That will never change, so I'm going to plug that in. Anything that changes has to be a variable. So both legs can change because you're going to be like sliding out. So I usually use x for horizontal and y for vertical, so that's what I've done here. In the problem, we are told that the ladder is sliding away from the base of the wall at 2 feet per second. So the distance from the foot of the ladder to the wall is x. If you're sliding away, then x is getting bigger, so dx dt is positive 2. With related rates problem, this is definitely related rates. Getting the signs of the derivatives right is really key, and you just have to think, like, does the thing get bigger or smaller over time? And that'll tell you if you should be using a positive or a negative rate. All right, now we need a relationship, but this is a right triangle, so Pythagorean theorem. I'm going to take the derivative of both of everything with respect to time, because things are changing with respect to time. Feet per second, right? Second is time. So the derivative of x squared with respect to time is going to be 2x dx dt. For y squared, we're going to get 2y dy dt. And then the derivative of 15 is 0 no matter what, or 15 squared is going to be 0. So now it's just plugging in. So I know that from the problem, we want the ladder to be 8 feet from the wall, so x is going to be 8. 8, 15, 17 is a Pythagorean triple. That's really where the typo was. I said that it was 15 feet long for the ladder, and I was like, oh, that's gross. So I'm going to plug in 8 for x, I'm going to plug in 15 for y, and I'm going to plug in 2 for dx dt, which looks like 2, plug in that 8, plug in that 2, plug in the 15, dy dt. Then we just have to solve for dy dt. So dy dt is going to be negative 16 over 15. And then the units on this, because y is the same as x and x is in feet, x is changing in feet per second, so y will also change in feet per second. All right, good problem, very typical. A lot of right triangle problems. I would say the vast majority of related rates problems kind of come down to right triangles at some point. All right, next up. A circle's radius is decreasing by 3 units per second, so getting smaller, so that's going to be a negative rate of change. Find the rate of change of the circumference when the radius is 8 units. All right, so this is a pretty straightforward problem, I think. As we discussed, drdt is going to be negative 3 because you're decreasing units per second, but like I didn't want to write them. We are usually on related rates. If I'm not sure what I'm doing or if there's a lot, I'll just write down everything I know. drdt, I'm being asked to find, let's say, dc dt for circumference, and when r is equal to 8. So those are the things I know. Just thinking about circles, I know that the circumference of a circle is 2 pi r. And I want to find rate of change with respect to time for everything. So dc dt is going to be 2 pi and then dr dt. And an interesting feature of this problem, it doesn't actually matter what r is, right? After we take those derivatives, there's no r anymore, there's only dr dt. So we'll just substitute in and get our answer. So dc dt is 2 pi times negative 3, which is negative 6 pi, and then units per second. So units per second, circumference would be measured in like, just units like feet, inches, not inches squared or anything. So just units per second. All right, that is the problem set. I hope you found this helpful and good luck.